All right, AP Calc students, Mr. Antonucci here, and we're continuing on with our series on interpreting a derivative, and now we want to talk about how to interpret it as an instantaneous rate of change. So let's start off with a problem. A population of killer bees has migrated to a town in the Midwest. Suppose the population P of killer bees in the town at time t in weeks can be modeled by this function right here. Find the initial number of killer bees that migrated to the town. So for part A, all we need to do is plug in 0, and you would end up with 1200 over 1 plus 39, because you have e to the negative 0.24 times t, which would end up being e to the 0. So that's 1200 over 40, which simplifies to 30. And here, because we have a context, we would have 30 what? 30 bees. If you had to interpret that answer, we would say that the initial number of bees that migrated to the town was 30 bees. Part B wants to know how many bees were there after 1 week. So we would substitute 1 into the function, and we get approximately 37.88, which rounds to 38 bees. Now, the second part of this is find and interpret the rate of change of the population of the bees after 1 week. So to get the rate of change, we're going to need the derivative. Now, you could evaluate the derivative in Desmos, but it's also important to understand how to do this by hand. So this is going to be taking the derivative with respect to t of, and remember the rule, if you have the derivative of 1 over a function, it's going to be the opposite of the derivative of the function over the original function squared. In this case, the whole denominator we're going to treat as g. In the numerator, you could factor out the 1200. So this would look like negative 1200 times the derivative of the bottom, which is going to be negative 0.24 times 39e to the negative 0.24t all over the bottom squared. Now that can look a little bit sloppy, but you don't have to simplify too much. Just multiply these constants in the numerator. Therefore, after 1 week, we would evaluate p prime of 1, and you would get approximately 8.804. So the interpretation here is important. That is, after 1 week, the population is increasing at a rate of approximately 8.8 bees per week. Now, when you're dealing with population problems, often we report population answers as whole numbers, but population rates of change are often reported as decimals, rounded or truncated, in this case to 3 decimal places. The units on this would be bees per week. So for part C, do the same after 20 weeks. So P of 20 would be approximately 908.43. So that's approximately 908 bees. And then P prime of 20, we would just plug in 20 to our derivative, and that's approximately 52.974 bees per week. So to interpret that, you would write out the sentence, after 20 weeks, there are approximately 908 killer bees in the town, and the killer bee population is increasing at a rate of approximately 53 bees per week. Now I want to talk about a quick tip for rate problems. You have to make sure you include a numerical value, the units, and the time, or the time interval, if that's appropriate, if you're doing like an average rate of change. So when you're interpreting and you're writing out the sentence, make sure you include the numerical value, the units, and the time or time interval. Now, we'll do one more example. The percentage A of a market penetrated by the Nintendo Switch gaming system is modeled by the function A of t, where t expresses the time in years since 2017, when the Nintendo Switch was first introduced. First, find A prime and interpret its meaning. A prime is going to be 90 times 0.12 e to the negative 0.12 t. This is because the derivative of the constant 100 goes to 0, and when you do u prime e to the u, the negative 0.12 multiplies the 90, making them both positive. So this simplifies to 10.8 e to the negative 0.12 t. So what this represents is A prime of t is the rate of change of the percentage of the market penetrated by the Nintendo Switch. In this situation, we won't have a numerical value because we're interpreting the actual function for the rate of change, not a specific value. However, in part B, we're going to evaluate it at 5, and you would have approximately 5.927. The units on that would be percent per year. And to interpret this, we would say at t equals 5 years, the percentage of market penetration by the Nintendo Switch is increasing by approximately 5.927% per year. All right, so that's instantaneous rate of change as an interpretation of the derivative. Hope that was helpful to you. Make sure you subscribe to the channel and leave me a comment if this was helpful to you.